What does it actually feel like to get stung by the most painful insect on the planet? Justin Schmidt spent years letting things sting him to find out, and the answer he came up with wasn't just a number on a scale. It was a description so vivid, it reads like a crime report. Pure, intense, brilliant pain that doesn't stop for 24 hours. No hospital visit required, no permanent damage, just your nervous system completely taken over by a single ant. And somehow, people have been doing this on purpose for thousands of years. Schmidt wasn't a lab researcher in the traditional sense. Most pain studies run through controlled settings where volunteers get measured doses and can tap out whenever they want. But Schmidt went into the field, got stung by whatever he was studying, and wrote down exactly what it felt like. He did this across years of fieldwork, letting over 150 species sting him because he'd noticed a gap that nobody had bothered to close. There was no shared language for comparing insect stings. That gap sounds small until you think about what it actually meant for the science. A fire ant and a tarantula hawk both sting. Calling both of them painful tells you almost nothing useful. The same way calling both a paper cut and a broken arm injuries doesn't help a doctor triage an emergency room. Schmidt wanted a way to compare them, so he built a scale from 1 to 4 and used his own nervous system as the measuring instrument. Now, the obvious pushback is that pain is subjective. What registers as a 2 for Schmidt might wreck someone else completely, and critics did point that out. It's a fair concern. But what the scale had going for it was something most pain research can't claim: perfect consistency. Same person, same baseline, same method every single time across every species. The numbers weren't the point. The comparative framework was. What really separated Schmidt's work from a simple ranking was the written descriptions he paired with each rating. A red fire ant scored a 1, and he described it as sharp, sudden, mildly alarming, like walking across a shag carpet and reaching for the light switch. You don't need to have been stung by a fire ant to understand that. You know exactly what that static shock feels like, so now you know what a fire ant sting feels like, and you know it's at the low end of the scale. That's more information than a single digit gives you, because it tells you the quality of the pain, whether it burns or stabs or throbs, and roughly how long it hangs around. By building out the lower end of the scale first, fire ants and sweat bees and paper wasps, Schmidt created a baseline that made the upper end genuinely alarming by comparison. You can't appreciate how bad a 4 actually is without understanding what a 1 feels like, and he gave you both in terms your brain could immediately process. What Schmidt ended up building wasn't just a personal record of how much things hurt. It showed that insect venoms are chemically distinct from each other, that they target different parts of the nervous system, and that the pain they produce is as varied as the insects themselves. Researchers picked it up as a standard reference because it gave the field a shared vocabulary for something that had never been measured this way before. And the insects that pushed that scale to its absolute limit didn't just cause pain. One of them shuts you down completely. 2 insects sit at level 4 on Schmidt's scale, and they got there in completely different ways. One hits like a bolt of electricity. The other burns slow and won't quit. The tarantula hawk is a wasp, and its biology is already strange before you even get to the sting. It hunts tarantulas, paralyzes them with venom, drags them into a burrow, and lays a single egg on the living spider so the larva has fresh food when it hatches. The sting it uses to do that isn't a defense tool, it's a hunting tool, built to drop a large, aggressive spider, fast enough that the wasp doesn't get killed in the process. When it stings a human, Schmidt described it as blinding, fierce, shockingly electric. He noted that the only reasonable response is to lie down and start screaming, and he wasn't being dramatic about it. For the first 3 minutes, you genuinely can't think or function. The pain takes complete priority over everything else your nervous system is trying to do. Now, what's strange about the tarantula hawk is what happens after those 3 minutes. The pain mostly stops. For something rated a 4, That's a short window, and it raises a real question about whether duration matters as much as intensity when we're judging how bad a sting actually is. Schmidt treated intensity and duration as separate things entirely. A sting could be catastrophic for a short time, or moderate for a very long time, and either one could land at level 4, depending on how you weighed the total experience. The tarantula hawk scores on pure, immediate intensity because that's what its venom needs to do. A wasp that takes several minutes to subdue a tarantula doesn't survive the encounter. The venom creates a neurological emergency fast enough to make the spider stop fighting, and when it hits a human, the same thing happens. Your body stops cooperating with you. Paper wasps sit around a 3 on the scale, but they show a different side of how cumulative exposure changes the math. Schmidt described their sting as caustic and burning, with a distinctly bitter aftertaste. One paper wasp sting is manageable for most people. 20 of them, because paper wasps can sting repeatedly, is a completely different situation. The venom isn't as intense per sting, but the total load on your nervous system adds up fast. So working through the scale from fire ants, up through paper wasps and into tarantula hawk territory, you can see that level 4 isn't one single experience. It's a category for venoms that overwhelm the nervous system, whether that happens in 3 seconds or gets there through repetition. Schmidt's description of the tarantula hawk tells us something the number alone can't convey. At level 4, your body stops being under your control. The venom doesn't just cause pain, it takes over. That's a biological fact, not a matter of degree, and the tarantula hawk isn't even the most complete example of it. Paraponera clavata lives in the rainforests of Central and South America, and it's close to an inch long, which is big for an ant. Schmidt rated it a 4, sometimes noted as 4+, and described the sting as pure, intense, brilliant pain, like walking over flaming charcoal with a 3-inch nail embedded in your heel. That description isn't just colorful, it's telling you something specific. This pain doesn't have an edge you can find and back away from. It surrounds you completely. The venom contains a compound called ponerotoxin, and the mechanism is actually quite simple once you see it. Ponerotoxin blocks voltage-gated sodium ion channels in nerve cells, and those channels are how nerves reset after firing. When ponerotoxin jams them open, the nerve keeps firing continuously. It's not a metaphor or an approximation. The nerve cell is physically stuck in a state of non-stop activation, sending pain signals to your brain on a loop with no off switch. Most venom compounds break down within an hour or 2. The body metabolizes them, the nerve channels recover, and the pain fades. Ponerotoxin doesn't follow that timeline. It stays active in tissue long enough that the pain cycle it creates won't break for up to 24 hours, which is why the bullet ant is called the 24-hour ant in Venezuela. No hospital visit speeds that up. There's no anti-venom in common use. You wait, and while you wait, the symptoms go well beyond pain. Muscle spasms, disorientation, and in some cases temporary hallucinations from the sheer neurological overload. Now consider that the Sateré-Mawe people of the Brazilian Amazon have been doing this intentionally for generations. Their initiation ritual for young men involves weaving hundreds of bullet ants, first sedated, into gloves with the stingers pointed inward, letting the ants wake up inside the glove, and then wearing them for 10 minutes. Not once, either. A young man completes this roughly 20 times over a period of months before the initiation is finished. The ritual isn't punishment, it's proof. The point is to show that you can endure something that shuts most people down and keep functioning anyway, and the fact that bullet ant stings leave no permanent damage is part of what makes it work as a test. You go through it completely and then you recover, and that recovery is built into the design of the whole thing. What Schmidt built wasn't just a ranking system for pain. It connected chemistry, behavior, and evolution across hundreds of species in a way that no single lab study could. And the Saturday understood the bullet ant's place at the top of that hierarchy long before anyone isolated poneurotoxin and explained why. Pain from an insect sting isn't random. It's information about how that insect has survived, what it needs to protect, and how it shapes the behavior of every animal around it, including us. There are insects further down the scale using completely different chemical strategies, and some of them you're far more likely to actually encounter.